We are going to start the set of 10 questions from the real analysis, the MCQ questions, very important for the CSIR NET exams. Alright, first one is the number of elements in the set A B such that 2a square plus 3b square equal to 35, where A and B belonging to the set of integers. What could be the number of elements for this set? Let's write the equation. 2a square plus 3b square equal to 35. We need to search the value of a and b such that this equation holds. We can take a to be 4 and b to be equal to 1. If I put a in place of 4, I get 16 here plus 3 into 1. 1 square is 1. So this is 32 plus 3, yes. We are getting this to be equal to 35. So 4 and 1, these values are valid for this equation. Because there is a square on a and b, we can also get the values as -4 and -1 for a and b respectively. So for the values of a to be plus minus 4 and b to be plus minus 1, this equation is valid. So what can be the set? It can be 4, 1. It can be -4, -1. It can be 4, -1, and it can be -4, 1. 4 set of values, right? Can there be any other values of a and b such that this equation valid? Can I take a to be equal to 2 and b to be equal to 3? Let's check this. 2 into 2 square 4 plus 3 into 3 square, that is 9. So this is 8 plus 27, that is equal to, yes, 35. So plus minus 2 and plus minus 3 for a and b. These are also valid for this equation to hold, right? So what are the other set of values? It can be 2, 3. It can be -2, 3. It can be -2, -3. And it can be 2, -3. So how many set of values we are having? We are having these total to be the 8 set of values, right? Can there be any other set of values for a and b so that this equation holds? Yes? I don't think so. Right? Let's move on to the next question. If x belongs to S, a non-empty set of real numbers, then which of these options are correct? S is a set of real numbers. Let's take S to be a bounded set. 1, 2, 3. Right? First option, what is the infimum of S? The greatest lower bound, that is 1. What is the supremum of S? The least upper bound, that is 3. Can these two are equal? No. So A option is not correct. The infimum of -s. What is -s? It contains the set of the negative values, right? What is the infimum value of -s? It is -3. What is the supremum value of -s? It is -1. Infimum value of -s, that is -3, equals to supremum value of -s, that is -1. Can this be equal? No. Okay, B option. Infimum value of s, that is 1, equals to negative of supremum value of -s, that is -1. Yes. These two sides are equal. That means B option is okay. Then infimum of s, that is 1, equal to negative of supremum of s, that is 3. No, this cannot be equal. So only B option is right. Next, if two sets A and B are having 99 elements in common, which means what they are saying, that A intersection B is 99. The number of elements in A intersection B is 99. Then the number of elements common to A multiply B and B multiply A. And means the intersection. Common means the intersection. How many number of elements will be present in this set? Let's solve this. This is equal to the number of elements in, okay, A intersection B multiply it with B intersection A. This is equal to this, right? Okay. I can write B intersection A to be A intersection B. That doesn't matter. So this is equal to what? The number of elements in A intersection B multiplied with the number of elements in A intersection B. It is a sign of multiplication. Or we can write this as number of elements in A intersection B whole square. And number of elements in A intersection B is given to be 99. So this is 99 whole square. So yes, B option is right. Next is fourth. An element A is a minimal element of the set S. What do you mean by minimal element of the set S? Suppose this is a set S. Suppose if A belongs to this set, then there cannot be any B element containing in this set. There cannot contain any B element in this set such that A is greater than B. Because A is the smallest element. If A is the minimal element, it is the smallest element present in S. There cannot be any other element which is smaller than A. There does not exist such B in this set. So for this condition, A belongs to S. Is this okay? They are only saying A belongs to S. They are not putting any condition over here that if A belongs to S, then A should be less than any other element present in S. It is not written over here. So we cannot take the option that only A belongs to S. There must be some condition with this option. So don't take this option. Similarly, we don't have to take the B option. A is not lower bound of S. How can this be possible? A is a minimal element. It is the smallest element in the set. Obviously, it is a lower bound of S. So, it is not correct. Yes, A is not the upper bound of S. Definitely, it is not the upper bound of S. Right? Fifth question. If the number of elements in A is 3 and the number of elements in B is 6 and A is a subset of B. Suppose this is your set B. A is a subset of this set B. B is having the number of elements 6. A is having the number of elements to be 3. It is having the number of elements 3. Set B is having the number of elements 6. If A is having the number of elements to be 3, then these 3 elements are also the elements of B. And because B is having the total number of elements to be 6, then the remaining set is containing 3 elements, right? So what is the total number of elements in their union? What is the union? The union of A and B is complete this set. So overall this set contain only 6 elements. Sixth part, if A, B, C are 3 finite sets, then what is the value for this? Let me solve this in this empty place. A union B intersection with C and its complement. By De Morgan's law, this is equal to A union B complement, intersection sign changed into the union sign, C complement. This is by De Morgan's law. Then again I am going to apply the De Morgan's law over here. It is A complement, union sign will change into the intersection sign, and then B complement, and then it is having union with C complement. So which option is right? Yes, C option is right. Fine? Okay. 7th, for every real number x, there is a positive integer n such that, let's take x to be equal to 2. Easiest one. 2 is a real number. Can I have the positive integer n greater than 2? Yes, I can have n to be equal to 3. It is a positive integer which is greater than 2. So A option is okay for this real number. Can I have any positive integer which is strictly less than 2? Yes, I can take n to be equal to 1. B option is also okay. Can I have n to be equal to 2? C option is also okay. So for x equal to 2, all these options matches. What if I take x to be the real number 0? what could be the option for every real number x? So for every real number x, only option A is right. Fine. Shall we move on to the next question? Alright. If q is equal to x such that x equal to 1 by y, where y belongs to the natural number, please keep this in mind, then which option is correct? Let me write this y to be equal to 1 divided by x from this. Option A, 0 belongs to q means we are taking x to be equal to 0. If I take x to be equal to 0 and putting this value over here, I get this to be equal to infinity. Is infinity a natural number? No. 0 and infinity are not natural numbers, because natural number is a counting number set that starts from 1 and it is a finite set but having no upper bound. We can have as large as possible any natural number but a finite set. That number cannot be equal to infinity because infinity refers to the unboundedness, right? So option A is not correct. Then 1 belongs to q. If I take x equal to 1 over here, what I get? This value to be equal to 1. Yes, 1 is a natural number. Okay, B is okay. 2 belongs to q. Putting x equal to 2 over here, I get 1 divided by 2. It is a fraction, not a natural number. So this is also not correct. Similarly, 2 by 3 is also not correct. That gives 3 by 2. That is again not a natural number. So only B option is right. Next, consider the following statements and tick the correct option. Phi equal to the singleton set. Can this be possible? What is phi? It is an empty set. Yes, it is an empty set having no element. What is a singleton set? It is a set containing one element. Right? So can an empty set equal to a set containing one element? Can first equation be represented like this? No. So option A only 1? No, it is not right. Second, singleton set is contained in empty set. Can this be possible? It looks so absurd. A singleton set cannot be the subset of an empty set. Right? So B option is also not correct. Both the options are also not correct. Yes, none of these equations are correct. The set of real numbers in the closed interval 0, 1 is uncountable. Alright friends, this is all about the set of 10 questions which are very important for the set theory and the real number system, the real analysis. Okay, thank you. Stay blessed.